Okay, so in this example, we are going to find the area enclosed by the y-axis, the curve, and the line y equals 0 and y is equals to 3. So if we were to expand the curve, we will get a quadratic function which is y squared minus 2y. Okay, so this is how the curve looks like. And how do we determine the 2 points here? So it is the y-intercept. So y-intercept is when x is equals to 0. So when you substitute x is equals to 0 from this equation, you know that y is equals to 0 and y is equals to 2. So you can label it 0 and you can label this 2. Okay. So the question says that the area enclosed by the y-axis, so we have a y-axis here, the curve, so we have already drawn the curve, and the line y equals 0 and y equals 3. So now we should draw the line y equals 0, so this is the x-axis, and also y equals to 3. So y equals to 3 is somewhere over here. So we can draw 3. Let me just highlight our boundaries to determine the area enclosed by the boundaries. Okay, so this is the line y equals to 3, and so the curve, so this is the curve, and we have another boundary at y equals 0, so this y equals 0. Okay, and also the y-axis. So if you were to look at the graph, the two areas which have its borders highlighted is this one and also this one. So these two areas are the areas which are enclosed by the y-axis, the curve, the line y equals 0 and y equals 3. So that two areas are the areas that we want to find. So we can separate the areas into two parts. So this will be area 1 and this will be area 2. So we'll be adding both areas together. So recall our formula to find area of a region bounded by the curve and the y-axis. So we'll have the interval. So we'll take from 0 to 2. So this will be solving for area 1. So we'll be solving this area first. So we take the right function minus the left function. So our right function is x equals to 0. So 0 minus. So our left function will be the one on the left. So left function will be bracket y minus 2. Okay. We will integrate with respect to y. So we put dy. And we add the integral from 2 to 3, right function minus the left function. So right function will have y minus 2 minus the left function. So left function is at x equals 0. So it will be 0. So there's no need for us to write the 0. We'll just straight away put dy. So if we were to simplify it, we'll get 2 integral from 0 to 2 minus y squared minus 2y dy. So the first integral will give you minus y3. So the first bracket gives you 4 over 3 minus 4 over 3, and the second bracket will give you another 4 over 3. So minus meets minus, so 4 over 3 plus 4 over 3 is equals to 8 over 3 unit squared, because we are finding the area, so the unit will be unit squared. So this will be our answer. To test yourself whether or not you have understood what have been taught in the slides before this, do try these exercises.